Okay, hello. So this is I'm Renata. And this is now my second video. In the last video, I talked about insulin and glucose. Ooh, my nails. I talked about insulin and glucose. So today I'm going to talk about type 1 diabetes and also type 2. I don't want this video, should back up a little bit. I don't want this video to be too long. Um, so what I've decided to do is I am going to show you the textbook that my school uses, my program uses, and this is the textbook right here. And I'm going to first read type 1 diabetes, this section, and it's located on page 1490. And if you have this textbook here, if your school uses, your program, I should say, uses this textbook for Med-Surg, here it is again, I am on page 1490. Okay, so we're going to begin. Type 1 diabetes is characterized by the destruction of pancreatic beta cells. So the pancreatic beta cells, which we know secretes insulin, and we know that insulin reduces blood sugar. Okay, it says combined genetic, immunologic, and possible environmental factors are thought to contribute to beta cell destruction. So, combined genetic, immunologic, and possible environmental factors such as like viruses, could play a factor that contributes to beta cell destruction. So what that means is that those factors could be why the beta cells are destroyed. However, become destroyed. But although the events that lead to beta cell destruction are not fully understood, it is generally accepted that a genetic susceptibility is a common underlying factor in the development of type 1 diabetes. People do not inherit type 1 diabetes itself, but rather a genetic predisposition or tendency toward the development of type 1 diabetes. So let me say that again. Although the events that lead to beta cell destruction are not fully understood, it is generally accepted that a genetic susceptibility is a common underlying factor in the development of type 1 diabetes. So some people are genetically susceptible of having type 1 diabetes, which again is just beta cells that secrete insulin are destroyed. So it goes on to say this genetic tendency has been found in people with certain human leukocyte, which we know are white blood cells, antigen types. So let's refresh our memory. And this is not, and I'll tell you something that my professors, both of them, have confirmed to me. Like, you really don't you don't need to really dive deep into the pathophysiology. But when you read something, even if you come across a word that, you know, you've seen before, you may have forgotten the definition, you need to refresh your memory. So an antigen is a toxin or other foreign substance which induces an immune response in the body, especially the production of antibodies. So an antigen is something that's foreign to the system, foreign to our bodies. So if we receive an antigen, it's either toxic, it's foreign, and then our bodies, which is our immune system, B cells, which are types of lymphocytes, will produce antibodies, okay? So people who have a genetic tendency to develop type 1 diabetes or be susceptible to type 1 diabetes, certain people have been found to have human leukocyte white antigen types. So, and then it goes on to say there's evidence of an autoimmune response in type 1 diabetes. And when you look in the A&P text, that's what they consider that the cause or what leads to type 1 diabetes is the autoimmune response. And we know that autoimmune means that the body is attacking itself. So in this case, the autoimmune response is to destroy the beta cells. And then this, of course, causes a person not to have insulin production, and I shouldn't say that because some people, young people, they may get to the age of prime example, 20, and then they start to have issues, or if they, uh, it just start, because I guess what we would say is, again, going back, a person is 20 years old, they had the onset of symptoms of type 1 diabetes. And of course, we know at this point, obviously, the beta cells are no longer sufficient. They are probably pretty much destroyed. 80 to 90%, Good Tech says, they just plain and simple as just their beta cells are not making insulin, and now they're starting to present symptoms of type 1 diabetes. Okay, so of course, an autoimmune source is abnormal, right? And in which antibodies are directed against normal tissues of the body. So that's autoimmune response. That's what happens. The body starts making substances, antibodies to fight against itself, which the body should not do. Okay, so now if you jump down to the next paragraph, it says, regardless of the specific cause. So just whatever the cause is, it's saying regardless of the specific cause, the destruction of beta cells results in decreased insulin production, increased glucose production by the liver, and fasting hyperglycemia. So because the beta cells are destroyed, a person will experience decreased insulin production, which we know we need to bring down blood glucose, and they'll experience increased glucose production. So think about it like this. Insulin, which we need to bring down glucose levels, is decreased. Insulin is not doing what it's supposed to do because it's basically not there. Now you have the liver producing glucose. So remember that the liver stores, when insulin works normally, properly, the way that it should, insulin will signal the liver to store glucose as glycogen. Glycogen is the storage form of glucose. So in this case, if you have something, we don't have insulin, and then we have more glucose being produced. That means that, of course, the person's blood glucose level is going to increase. And then fasting hyperglycemia occurs. So let me read that again. Regardless of the specific cause, the destruction of beta cells results in decreased insulin production. Insulin is not signaling cells, the liver, the muscle cells, to do what they need to do with insulin. And then because the beta cells are destroyed, insulin is not there to do its job. So the body will signal the liver, actually glucagon and some other hormones, and we'll get to that, to produce, we'll tell the liver, let me back up. The liver will increase its production of glucose. And the reason why the liver does that is because there's hormones that signal it to say, hey, we need more glucose, when in case we don't really need more glucose. But that's just how the body responds. That's how the body is responding to the destruction of beta cells, unfortunately. So, and then they say, in addition, glucose derived from food cannot be stored in the liver, but instead remains in the bloodstream. It continues to and contributes to after meals hyperglycemia. So, what that is saying is that remember that insulin signals, and I said this, and I guess I don't want to keep repeating myself, but remember, this is because insulin is not inhibiting glycogen from being converted to glucose. Because if insulin is available the way that it is, the way that it should be, there's no need for the liver to break down its storage of glycogen and turn it into glucose, because insulin is there doing its job. It's just no need, right? So so of course, when after we eat, our blood sugar goes up. Because that's natural. You're eating, the body is breaking down carbohydrates, glucose is being released, glucose is going to get into the blood before it gets to the cell, so of course your blood sugar is going to go up. So now the kidneys are responsible for reabsorbing glucose. because we wouldn't want to lose glucose, right? Because we need it, because I said in the last video, we need it for cellular respiration. So we don't want to really get rid of it, especially when we don't have to get rid of it. We can store it. So forgive me. The kidneys can handle no more than 180 to 200 milligrams per deciliter of glucose. So remember that the kidneys filter blood to make urine. So if that blood is filled with glucose coming past the kidneys cannot handle but so much glucose. They can't handle but so much sweet blood. That's what it is, right? So if the kidneys can't reabsorb it, they say, you know what, I'm overwhelmed, it's too much, then they're just going to have to take this, let glucose run down the tubules and just let glucose be secreted into urine. Now, the issue is with that is that when glucose isn't reabsorbed by the kidneys, forgive me, of course we know glucose to be in urine, but then excessive will also lose water. And a way that you can, and I want to say that I have heard this before, and I'll double check, and I'm going to ask my professor, but you know, basically you can think of it as that glucose is going to pull water along with it, because remember that water moves from high to low. So if it's less concentration somewhere, water is going to move where there's more concentration. So there's more glucose in the blood, the kidneys filter blood, it's going to pull water and pull glucose. So that's why people want to be always having to go to the bathroom. So here it says when excessive glucose is excreted in the urine, it is accompanied by excessive loss of fluids and electrolytes. So not only the kidneys are going to just take this is pretty much, they're not going to absorb, well, not pretty much, it is. They're not going to absorb glucose. They are not going to absorb, hold on just a second. Hey, mama. Hey, boo.
Hey, boo. What you want? What you doing?
Nothing. I'm recording a video. Can I call you right back? You all right?
Okay.
I'm gonna call you right back, okay?
All right.
All right, boo. So sorry about that. That's a friend and a classmate of mine. So, yeah, so when, forgive me. Yeah, so when, oh, I lost my train of thought. Yes, we were talking about the kidneys and the glucose. So basically what happens, so as this is the simple point that you need to know, is that the kidneys don't reabsorb all of filtered glucose. They don't reabsorb all of it. So the glucose that it doesn't reabsorb, it gets excreted into urine. And then again, water follows the glucose, and then you're going to lose so it's going to be glucose in the blood. You're going to have excess water and electrolytes loss. So you're going to have excessive loss of water, excessive loss of electrolytes. And right there, we already know that we lose electrolytes. You know, you're going to have imbalances. And then it'll go on to talk to us about the types of electrolytes that'll be lost. So this is called osmotic diuresis, and that makes sense because, again, we know that water is going to move from high to low. So that's why, because water is going to follow concentrations, high concentrations. So because insulin normally inhibits glycolysis, and that's the breakdown of glycogen, and glyconeogenesis, which is the building of glycogen, these processes occur in an unrestrained fashion in people with insulin deficiency and contribute further to hyperglycemia. So you have no insulin and you just have glycogen breaking down, glucose being made from glycogen. So that's unrestrained. So there's nothing checking it. It's just going to happen because insulin is not there to stop it, because that's one of its functions. It prevents it, again, because there's no need for the liver or the muscles to convert glycogen to glucose because insulin is doing its job. Obviously, when insulin is not there, it's going to cause glucose to be produced because it's like, okay, the body is like, okay, insulin is not there. Obviously, you need some more glucose, but that's not the case. We don't. The blood is already filled with glucose. Okay. So in this case, what happens when more glucose is sitting in the blood, they're not, the cells and the muscle and the liver are not being signaled to do something with that glucose, then the body has to save itself. So okay, I can't use the glucose, so now I got to go to fat. And when the body has to start breaking down fat, ketone bodies form, and this is not good. This is why type 1 diabetics normally experience diabetic ketoacidosis, and that's because, again, they have glucose in the blood, but nothing is being done with it. So the body has to go to the next best thing. Go ahead and let's use some fat. But when it uses fat to make energy, ketone bodies, which are acidic, makes a person in an acidosis state. And that's basically what ketoacidosis is. And that's something that type 1 people are particularly susceptible to, is because, again, their beta cells, it's not like they're making enough. The text says 80 to 90% of those beta cells are being destroyed. So if something is destroyed, it's not making it. It doesn't have it, okay? So that's what you have to understand with that. And that's type 1 diabetes. So now you have to understand, this is a person, of course, type 1 diabetes. Their body eventually is just showing signs of them not being able to control their blood sugar. Their blood sugar is elevated, of course, and now they're showing signs and symptoms, and they need to control insulin, to control blood glucose. They need to have insulin injections because they're just not making any insulin, and you have to have it. So that was said by my professor. So now, diabetic ketoacidosis is a metabolic disarrangement that occurs most commonly in people with type 1 diabetes and results from a deficiency of insulin. Highly acidic ketone bodies are formed and metabolic acidosis occurs. Now, metabolic acidosis, we know we know what that is from here. It's a metabolic issue. Metabolism isn't running properly. So because the metabolism isn't running the breakdown and building of compounds isn't running right. So now fat is being used, and now the body's in an acidic state, so it's metabolic acidosis. It's a metabolic issue which is causing the body to be in an acidic state. So it goes on to say the 3 major metabolic disarrangements are hypoglycemia. We know why that's happening because insulin, there's no beta cells to secrete insulin, so glucose is going to go up. And then ketosis, which again is the acidic state, and then metabolic acidosis. Now, ketosis is again the production of ketone bodies which are acidic, which causes the metabolic acidosis. Now, it goes on to say that DKA is commonly preceded by a day or more of polyuria, that's increased urination, which makes sense because, again, the kidneys cannot be overwhelmed with glucose because the only thing it's going to do with it is filter the glucose, let it run in urine, pour water with it. Okay, so that's the polyuria, and then you have polydipsia, which is thirst. You're going to be thirsty, and the reason why you're going to be thirsty, why? Because you're losing so much water. So, remember the thirst mechanism, the hypothalamus has our thirst center. So the body is going to signal you to say, hey, drink. And that signal, of course, is thirst. And then you have nausea and vomiting. That's probably because you're losing those electrolytes. And you have fatigue. And it says with the ventral stupor in coma if not treated. So these people have to be treated right away. You cannot live in an acidic state. And then the breath has a characteristic fruity odor due to the presence of keto acids. It's another word for ketone bodies. So the fruity smell that you with these patients, if they experience DKA, is because of the keto acids, the ketone bodies being formed in the body, being formed from fat breakdown. Remember fat breakdown, because you have to have fat breakdown to make energy. Because remember what I said the last video, you got to generate ATP. So that's type 1. So now that I've read that, I may have rambled a bit, got distracted, but let's just understand what it is quickly. Destruction of beta cells. The beta cells are making insulin. If insulin is not being made, glucose is not being taken in by cells. It's not being stored by the liver. It's not being stored by the muscles. Fat is, forgive me, and then fat does store glucose as fat, but obviously that's not happening. The fact that so let me back up. So then, okay, let's talk about the cause. The cause, they say, is an autoimmune response. Your body is attacking the beta cells. That's what it is. It's the reason why your beta cells aren't producing any insulin, because they're being destroyed by the body itself. All right, so that's the cause. So then to go back, and we talked about what happens. We know that the person is going to experience hyperglycemia. We know that the kidneys aren't going to be able to reabsorb glucose. So the person is going to have glucose in their urine, and the glucose is going to pull water and electrolytes. So you're going to lose too much fluid and electrolytes. So, and that's because of osmotic diuresis. Forgive me, it's well, you can say it's caused or it's due to osmotic diuresis, right? So now we know that a function of insulin, when it's working properly, is to stop glycogen from breaking down and being converted into glucose. Because with that's only just, one, you don't have insulin, so your blood sugar is going to be high. And then two, you don't have anything to check the liver from stopping, from making glucose and releasing it to the bloodstream. So what's going to add more is to hyperglycemia. What I'm trying to say is your blood sugar is going to be increased even further. So then, because glucose doesn't have insulin to tell it what to do or where to go, the body is going to start breaking down fat. And when you break down fat, ketone bodies are produced. They're acidic. Your body's going to go into an acidic state. And the symptoms that we're going to see for those patients experiencing diabetic ketoacidosis, those things are going to be the increased urine, increased thirst, nausea and vomiting, fatigue, and eventual stupor. Like people who just kind of sleep and you just can't get them up. They just seem out of it. Eventual stupor and coma if not treated. And you know what? Yeah, here Rika said, out of it, a state of near unconsciousness or insensibility, a stupor. Yeah. So, and then you're going to have a coma, which you are unconscious when you have a coma. And that can stupor, and eventual stupor and coma may occur. What does this say? No, it says with eventual stupor and coma if not treated. And again, the breath is going to smell fruity. Why? Because ketone bodies are being produced. So that's type 1 diabetes. So in type 1 diabetes, you have to understand. So I guess I have a problem with this. We have to move past understanding what the disease is. We have to get a good understanding of that. Then we got to move on to how type 1 diabetes is treated. But so type 1 diabetes would have to be treated with insulin. You have to get insulin injections because, as my professor said, and which makes sense, you cannot live without insulin. So if you can't live without it, you got to get it from the outside, right? So they're going to inject insulin into you. And people with type 1 diabetes have to get insulin injection. So they actually have to get the hormone injected into them. So I'm going to just briefly go over pharmacological therapy, and this is on page 1499, to talk about insulin, because we already know what happens when the person doesn't have insulin. So how do we get that person insulin? And once we get them insulin, what's going to happen? And how do we manage their therapy with insulin, right? So that's what we need to know. And that's what I am struggling with. So this video is now 25 minutes. I'm trying to think, should I stop it? Yeah, I'm going to stop it here. I'm going to stop it here. I'm going to listen to it. I don't care. That's one thing. I'm not a YouTuber. I'm just trying to help myself pass this class. So I'm talking through some things. So I'm not editing. I'm not a teacher. I'm a student. This is a study tool for me. If somebody takes this information and they go back and verify it with their textbook or with their professor or with their study group, cool. But I'm in no way calling myself trying to teach someone something. I have to verbalize these ideas. So these were ideas, these concepts, like, have to do something different, because yeah. Okay, so yes, I'm going to go ahead and stop the video now. Thank you for listening, and I will record another video to talk about the pharmacological therapy for patients who are type 1 who have type 1 diabetes, because remember I just said that those with type 1 diabetes, they have to get insulin injections, and insulin is very it's a very sensitive medication. You just can't, and they actually call it a regimen. So because at the point of insulin therapy, as we've been told, and as I've been told and read, that it's a regimen because they're trying to get insulin therapy to mimic what the pancreas will normally do. And we'll get more into that in the next video. So thank you. Bye. Oh, wait a minute. Which way am I? Oh, yeah, here I am. Bye.